The steady state error of a unity feedback linear system for a unit step input is 0.1. Okay, the steady state error of the same system for a pulse input r of t having a magnitude of 10 and a duration of 1 second as shown in the figure is. Okay, so it is given that for a unit step input, okay, the steady state error is, let us take it to be ESS1, okay, because we are dealing with two different inputs here. Okay, for unit step input, the steady state error ESS1 is equal to 0.1. Okay, so this is what is given. Now for a pulse input, the pulse input will be like this. Okay, it has a magnitude of 10 and it exists for a duration of 1 second. Okay, so for pulse input r of t, we now have to find out the steady state error. Okay, now what is the expression for steady state error? The general expression for steady state error will be limit s tends to 0 s into the input function, okay, let us take it to be some u of s, okay, divided by 1 plus g of s, right? So this is the expression for steady state error. Now for unit step input, we will get ESS1 is equal to limit s tends to 0 s into 1 by s. Okay, for a unit step input, u of s will be 1 by s divided by 1 plus gs. Okay, so this is equal to 0.1. So this we can write 0.1 is equal to s and s will get cancelled. So you will get 1 divided by 1 plus limit s tends to 0 g of s is 0.1. Okay, so this expression we will remember. Now we will try to find out ESS2, okay, steady state error for pulse input r of t. So r of t we can write as the magnitude is 10 into u of t minus u of t minus 1. Okay, why is this? Because u of t will be like this, okay, and minus u of t minus 1 implies that it is a function which has a magnitude of minus 1, okay, and it is starting at t is equal to 1. Okay, so it is starting like this. So if these two functions u of t and u of t minus 1, if you add up, then you will get this function. Okay, and into 10 will give the magnitude 10. Okay, so this is the expression for the input pulse. Okay, now what will be the Laplace transform of it? This will be equal to 10 into u of t Laplace transform is 1 by s. Okay, u of t minus 1 is a time shifting function. Okay, so this will have e to the power minus s divided by s. Okay, so you can use the property of the time shifting property and you will get this function. Okay, so this entire thing is the Laplace transform of the input. Okay, now ESS2 is equal to limit s tends to 0 s into the input function, which is this function, right? So you will write 10 into 1 by s minus e to the power minus s by s divided by 1 plus g of s. Okay, so this you can write as limit s tends to 0, s and s will get cancelled, 10 into 1 minus e to the power minus s, okay, into limit s tends to 0, 1 by 1 plus g of s. Okay, so we can separate like this. Okay, so this value, you know, this is 0.1. Okay, this is already there. Now what is this part? Limit s tends to 0, 10 into 1 minus e to the power minus s. if you substitute s is equal to 0, this will become 1 and 1 minus 1 will become 0. Okay, so ESS2 will be equal to 0. Okay, what will be the option? It is option A.